Let's talk about Newton's third law here, and this is how forces relate to one another. So jumping on in, Newton's third law says for every action force, there is an equal and opposite reaction force. So in other words, the force of object A on object B is going to be equal to the negative of the force of object B on object A. So you'll notice they're equal because the magnitudes are the same, and they're opposite because we've got this negative sign in here. So they are not the same force, they're not completely equal, they're equal in magnitude and opposite in direction. So you can think about magnitude if you want, opposite in direction if you want. These forces are, like F of A on B and F of B on A, are called action-reaction pairs. And there's a couple important facts to know about action-reaction pairs. In order to determine if two forces are an action-reaction pair, then there's exactly two objects involved. You can never have an action-reaction pair with three or more objects. So there are never more than two objects. If you say F of A on B is equal and opposite to F of B on C, that might be true, but they're not an action-reaction pair. The forces always act on different objects. So if you see A acts on B, B acts on A, you don't have A on B, C on B, because those would act on the same object. So they always act on different objects. What we already said before, forces are always equal and opposite. So that one should hopefully be pretty easy to tell. And then lastly, they were always the same type of force. So broadly what that means is it should be either they're both pushes or they're both pulls. So you can't say F of A pulls on B, F of B pushes on A. That's not going to be an action-reaction pair. That may be happening, but it's not an action-reaction pair. And if you want to be more precise, they need to be the same type, as in they both need to be gravitational, or they both need to be normal, or they both need to be tension, or something like that. So let's look at some examples. So for example, Mr. McKinnell pushes down on the desk. The reaction force would be the desk pushes up on Mr. McKinnell. So we look, how many objects are involved? Two, Mr. McKinnell and the desk. What are the forces acting on? In one case acting on the desk, in one case acting on Mr. McKinnell. They're on different objects, great. Are they equal and opposite? We don't know that they're equal, it's implied from the statement here, but they are opposite. We've got down, we've got up. They are always the same type. They're both a push, and so this works. We kind of met all those conditions. We have Mr. McKinnell pulls on chair to the left. Chair pulls on Mr. McKinnell to the right. Okay, let's double check. How many objects? Two, chair and Mr. McKinnell. Are they acting on different objects? One's the chair, one's Mr. McKinnell. Great. One is left, one is right. Great, they're both poles. This is an action-reaction pair. This is something that you are going to get mixed up with more than likely at some point. So just continue to swing back to these as our definition and as our idea. And don't assume just because two forces are equal and opposite that they must be an action-reaction pair. Check to see if they're an action-reaction pair.